Welcome. So we're now going to talk about using recurrence matrices to model populations. And this is going to involve learning about the forcing term. And what we're going to be looking at is now a formula that looks like this. And as you can see, the way that this is different to what we've previously seen is that we've got this b on the end. So if we look here at our formal definition, we know that S subscript 0 is our initial state. And then S of n plus 1 is equal to our transition matrix multiplied by S of n. That's all very familiar. What is new is this b here. And this b is what we call the forcing term. Forcing term. Now, what is this forcing term? And why have we slightly changed our formula? Well, let's read through this, and it will give us a bit of an understanding of why we've done this. So far, we've only considered situations where the total number of people or objects remains the same throughout. In some scenarios, we need to consider what will happen when the total number of people or objects changes. In these cases, the transition problem is modeled by the following recurrence relation. So here's the recurrence relation that we're going to use, and we use it when the total number of people or object changes. Up till now, they haven't changed. We've merely kind of just rearranged things, but up till now, the total number has remained the same throughout. What we're now going to see is what happens when we have this forcing term, which is actually going to cause a change to the overall total. And the reason why we call this, population modeling is because if you think of, say, a population of, this next example that we're going to go through is antelopes. If you think of a population of antelopes, not only are they going to change like where they're living, like in this example down here that we'll see soon, the antelopes could go the east, the west, the north, they're going to change around. But unfortunately, some antelopes are going to die as well. We're actually going to change the total population of antelopes. So this forcing matrix is kind of taking into consideration the fact that some antelopes are going to die, some are going to be born. There's going to be a change in the overall population. And that's why we use this type of recurrence relation when you have a change in the overall total number of people or objects. So with that introduction, let's now dive into this first example.